All right, we're going to talk about the constant rate of change for our notes today, and it's just a continuation from what we talked about in class. So let's go on and put in our entry for our date. We're going to do 9/30/15. Can't believe September is already pretty much over with. All right. So basically what we're going to do is we're going to find the rate of change for a table and a graph. So here we go. Directions, find a unit rate to determine the constant rate of change. So to show, the table shows the amount of money a school club makes washing cars for a fundraiser. Use the information to find the constant rate of change in dollars per car. So remember, K equals Y divided by X. Okay? And K is what stands for your rate of change. So right now, write this in. K equals rate of change. All right? So the number of cars being washed, that's going to be your X. The money that's been spent is the Y for this, okay? So we want to find the rate of change. So basically that means the unit rate. How much does it cost to wash one car? We want to know the price per one car. So let's go ahead and set it up and solve for it. All right. So the top part, this is going to stand for our Y, because remember it's Y divided by X. So we're going to talk about the change in money over the change in the number of cars being washed. So number of cars. So if I start with 80 here, okay, and I subtract it from 40, because we want to talk about that change, I would do 80 minus 40, okay, and then I would want to take the 10, because that's the one that's shared with the 80, the number of cars. It costs $80 to wash 10 cars, so I need to use the 10 cars. And then the 5 cars cost $40, so I'm going to use the 5. So 10 minus 5, all right, and then we're going to scroll down over here. And we're going to write what we got when we did 80 minus 40 and 10 minus 5. So we're going to put it right here because this is where we want to find it as a unit rate. So 80 minus 40 gives us 40. And 10 minus 5 is 5. 40 divided by 5 means that it was $8 per one car. So over here where it says the money earned increases by $8 for every one car. So for every car that's being washed, the shop charges them $8. So in our table, okay, in our table, it just shows us 5, 10, 15, 20 in intervals of 5. But if I wanted to know for, say, 8 cars, I would do 8 times 8 and get 64, because that's the cost per car. All right. So down here where it says the number of dollars earned increases by $8 for every car washed, we're going to write $8 for every car washed. And that's how you do example number 1. Mainly what we're going to do is just go through examples through this, guys. All right? And then remember to go on to Canvas, log in, and take your quiz. Okay. Let's go to the next problem, example number 2. All right, on this one, it says find the unit rate to determine the constant rate of change. So that's what we're doing again. Highlight and underline important information. So the table shows the number of miles a plane traveled while in flight. Use this information to find the approximate constant rate of change in miles per minute. Now, we're used to doing miles per hour. This one is miles per minute. Okay? So the time is going to represent our X, and the distance will be our Y. So I'm going to take the difference between my two times. I'm going to do 580 minus 290, because that's my Y. Remember, Y over X. And then I'm going to place that over 60 minus 30. Well, 580 minus 290 gives me 290. And 60 minus 30 gives me 30. And when I divide those two, I end up with 9.6 repeat, or 9 2/3. All right, because 9.6 repeat is 9 2/3. Now, at first when I did this, I was like, that doesn't make any sense. Who travels 9 miles per hour? But the question was saying per minute. So the answer to this would be they travel 9 2/3 miles per minute. All right? If I wanted to figure out how fast they were going per hour, I would multiply that time. I would multiply that 9 2/3 times 60. Okay? So the answer to this would be 9 2/3 miles per minute. And that's the answer. Remember, we're trying to solve for k, which is our unit rate, or our rate of change, and k is y divided by x. So we take two of our y's that are, side by side, and we put them over two of our x's that are right next to each other as well, and and divide them both. All right, let's go to the next example. Let's scroll on down. Okay, the table shows the number of people that buses can transport. Use the table to find the constant rate of change per bus. So we're talking about per bus. Okay, the number of buses is our x. The number of people is our y. So it doesn't really matter which two you choose to take from. You could take from the first two right here. Okay, these two. Or you could opt to do from these two. It doesn't matter. Okay. So this time, let's choose to take 360 minus 288. So, remember, it's going to be the number of people. So, people over the buses. Okay. And we're going to do 360 minus 288. And then we're going to do 5 minus 4. We got to use the numbers on the table that match up with the 360 and the 288. And 360 minus 288 equals 72. And then 5 minus 4 would be 1. So right there it means that I'm going to have 72 people per one bus. And that's the answer that we're looking for. 72 people per one bus. And that's your answer. Like I said, this is a review of what you've been doing since 5th grade. So let's go on and go to example number 3. Okay, on this example, though, we're going to use a graph this time, okay, which is showing us with quadrant 1. And in class, I told you that whenever you're looking at a graph and you want to know if this is something that's proportional, this graph actually doesn't even pass through the origin like it's supposed to, so this graph is not going to be proportional. All right, so let's go on and set this one up. It says the graph represents the number of candy bars sold at the school fundraiser. Use the graph to find the constant rate of change in numbers per hour. So to find the rate of change, pick any 2 points on the line. So right here, I'm at 8 p.m. and 25. So that's our first hour. Okay, so, let me write that down. Okay, so right here, I'm going to say this is our first hour. So that's going to be labeled as a 1. 9 p.m. is going to be labeled as the second hour, and 10 p.m. is going to be labeled as the third hour. So for the 8 o'clock one, for the first hour, okay, the first hour they sell 20 candy bars. So that's 120. Actually, not 20, excuse me. It says at the 0 hours, let me erase that. It says at 0 hours they started and they sold 25. Or not 25, 20. So 0 and 20. And then 1 hour is at 25 minutes. There we go. Sorry about that. And then 2 hours is going to give us, what is 2 hours? Let's see, here's 2 hours, and I'm going to go up 30. So 2 hours, we sell 30 bars. And then 3 hours, we sell 35. Okay? I guess I should have written it all here in this box right here. So if you want to move it over here and write it in this box, that's fine. 0, 20. Okay. 1 and 25. 2 and 30. And 3 and 35. All right. Let's move up to what we have here. So right here, the change in blank over the change in blank. So we're talking about our y-axis first. So the y is talking about the candy bars. So right here, the change in candy bars. And then the change in time. Okay, so let's pick two numbers that are back to back. I'm going to do 1 and 2, the first and second hour. So look at your y. For the first and second hour, we're just going to focus on the y. So this is the first. We're going to use this one here and this one here. So look at your y right now. Okay, and we're going to do 30 minus 25. And then the x for that one would be 2 minus 1. Well, 30 minus 25 is 5, and 2 minus 1 is 1. So basically it's saying that every hour they're selling 5 candy bars. So for every hour they're selling 5 candy bars. So let's scroll down right here. This is the same stuff. This information here is the same stuff that we have here. So 30 minus 25, 2 minus 1, that gives us 5 per hour. So 5 candy bars, 5 bars per 1 hour. And then put it down here as your answer. Now this is not a proportional relationship because it says that at 0 hours, they've had already sold 20 bars. Alright, if it was proportional, it would have been 0, 0. Okay, so this is kind of like that gym problem where we started out with $35 for the very first part. Alright, whoops, I don't know what I just did there. Okay. Alright, so just so I reiterate what I just said, I'm going to scroll to the top. Right here, see, it's saying 0 hours, they had sold 20. This is where it's not proportional. Had it been proportional, the line would have passed straight through the origin right there. So this is not a proportional problem. Okay. Let's go to our last problem in our packet. All right, find the unit rate. So here we are finding the unit rate or the constant rate of change again using the points. Remember, you need to use any 2 points. Make sure there are 2 points located side by side. This one is talking about the temperature in hours. And so the formula for this to find your unit rate is K equals Y divided by X. So my Y is my temperature. I'm going to abbreviate that. And then my X is the hours. Alright, so I'm going to say the first hour is, we're going to use, let's use these. Let's use hour 2 and 3. Okay? So for the third hour, the temperature was at, what's the third hour? 65 degrees. Okay, and then the second hour, the temperature is at 70 degrees. All right, and if you notice, look at the graph. What way is our equation, our line graph going? Is it increasing like this, or is it going down and decreasing? It's decreasing, which means the temperature is dropping over the number of hours. So maybe it's like 2, 3 o'clock in the afternoon, right here, and then over the hours, the temperature continues to drop and drop and drop because the sun's going down. That would be a great example of a problem like this. So let's go ahead and do that. Let's take our 65, okay, and subtract 70. And you're thinking, wait, Miss Garcia, that's backwards. Remember, the temperature is dropping, it's decreasing, it's going down. So we are going to have a negative degree because the temperature is decreasing. And then we're going to do, at the third hour is when it was at 65, so 3 minus 2. 65 minus 7 is a negative 5, and 3 minus 2 is 1. So what's happening is it is dropping 5 degrees every hour. Okay, so K equals negative 5. Okay, or if you wanted to put it in words, dropping 5 degrees Fahrenheit per hour. Okay, or you could say negative 5 degrees Fahrenheit per hour. Dropping and negative meaning the same thing. Let's scroll down here to this next example. This one's talking about meat consumption. So the number of people and the pound of meat. So our pound of meat, remember, you need to memorize this formula where it's K equals Y divided by X. Okay? So where Y equals the meat and X equals the people. And if you pay close attention to this one, it's passing through our origin and it is a straight line. So therefore this is a proportional graph. So let's just take the 1 and the 2. Okay, so actually, you know what? Let's change it up. We're always using the first two. Let's use the 4th and 5th person. So the 5th person, okay, they buy 15 pounds of meat. Okay, and I'm going to subtract it from what the 4th person buys. So right here, this is what I'm talking about. Okay, the 4th person buys 12. So 15 minus 12. And that's for the meat. Now the people, I need to use the 5 and the 4. So 5 minus 4. And 15 minus 12 would be 3. And 5 minus 4 would be 1. So that means that every one person is buying 3 pounds of meat. So basically the butcher shop or bakery would be cookies and donuts. Don't know why I said that. The butcher shop, okay, would be selling 3 pounds per one person. All right? And that's it in our notes. I more or less just wanted to go through examples showing you how to use a table and how to use a graph to find out if something was proportional or not. I'll see you tomorrow in class. Have a good night, guys. Oh, before I forget, your K, okay, is 3 pounds. This is your K. So your rate of change is K. Or excuse me, your rate of change is 3. Okay? So K in this problem would be 3. And let me make sure I did it for the other one. Okay? Yep. So I did remember to put K equals -5. All right. See you tomorrow, guys.